Ionic compounds are two or more elements chemically bonded together to form a neutral compound. With the cation and an anion, a positive and a negative, you make a neutral compound. That's what we're looking for. So, example, you have sodium 11 and you make the electron configuration that gives you valence electron 1. The important thing you need to know is the ionic charge. And the ionic charge of 1 valence electron is 1. So, plus 1. So, you have Na plus 1. Now we're looking for a negative ionic charge. Now we have chloride, which is 17. We do the electron configuration, which gives us 7 valence electrons, and 7 valence electrons is negative 1 ionic charge. Okay? So here it is. Chloride, negative 1. Now, what we need to do, and you need one cation and one anion, one positive and one negative to have a neutral compound, which is an ionic compound. Now, what we're going to do is, we're going to circle this one, circle that one, we're going to cross it, we put NaCl. You change these two, but since it's 1, the 1 you never place it, because, well, this is 1, okay? So it stays like that, but we put here its names. And here's the answer. Remember that always the anions end in ID.
We're going to do another example with K, which is potassium, and it has 19. And then S, which is sulfur, and it has 16. So then we will do the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6. How many do we have here? We have 10, 12, 18. We need just one more, 4s1. Remember that we already gave you the electron configuration in another part of the video. And then, right here, our highest number is 4, so that is our period. We have 4, and then our group is S1. Remember, if we had an S1, it was 1A. But the important thing, as Ana Paula said earlier, is that we have the valence electrons. So the valence electron here, we don't have to add them up because there's only one top number. And then here, I'm going to show you an easy way to know how many valence electrons one element could have. If the element is located in the A section of the periodic table, then if it's in the 1A, it will only have one valence electron. If it's in the 2A, it will have 2 valence electrons. But this only applies to the A section. So if you have 7A, that element will have 7 valence electrons. Well, anyway, this only has 1 valence electron, and the ionic charge of 1 valence electron would be positive 1. So then the potassium, the K, is positive 1. And then here is sulfur. So we have 1s2, 2s2, 2p6, 3s2, 3p6. Right here we have 10, 12, 18. We have 2 more. So we have 4. Now we have 10, 12, 16. And then our highest number, the period, this is not necessary, but it helps me know what I'm doing, so I do it. Like the period and group is not necessary, only the valence electron, but it helps me. So you can do it if you want to. So here, the period is 3, but it has 2 parts to find the valence electron. So our valence electron will be 6. And 6, its ionic charge is negative 2. So then the sulfur has negative 2. So as you can see, we have our cation and our anion, okay? And then we switch them up. We put the 1 down here and the 2 down here. And the signs do not matter. You do not have to put a positive 1 or a negative 2 over here. It does not matter. So then we will have K2S1, but this is already 1S. We don't need to show it. And the reason why we're putting a 2 here is to know that we need 2 potassiums to get to our 8, because we get the elements together to get to 8, because as we said before, all elements want to get. The reason why the 2 is here in the potassium is because it's telling us that we need 2 potassiums to get to 8. Remember that? all the elements are trying to get to 8 valence electrons because it's like their goal. So here to get to 8, they use 1 sulfur and 2 potassium. 2 potassiums because 1 potassium has only 1 valence electron and a sulfur has 6. So if you use 2 potassiums, you have 2 valence electrons and then you have 6 in the sulfur. Plus 6, it gets us to 8. That's why they get together. And that is making a neutral compound. So right here, we would have K2S. And then the naming would be, it would be potassium. And then you use a parenthesis to show the number, like what it had before. But you use the one here, not the one here. So it would be 1 sulfur. And you don't put a parenthesis at the end. It is only between them. But since the 1, it doesn't count because you already know you needed 1 potassium. So you don't use it. So the answer is just potassium sulfur. It is K2S, potassium sulfur.
And then we're going to do these examples that are calcium, that is 20, and oxygen, that is 8. And first we have to do the electron configuration, and then we have to classify them by the group and period. In this case, the group is 6A because of the P4, and the period is 2 because it's the biggest number here. And then in this one is 4, the period, and the S2 is the group, so it will be 2A. Then we're going to have to do the ionic charge. And in here that we have 2A, we have to search for the 2, and it's plus 2, so calcium, its ionic charge is plus 2 cation. And then here in the oxygen is 6A, so the ionic charge is minus 2, so it's anion. And then we have to cross them. That this leads us to Ca, calcium, 2, oxygen, 2. And then we have to simplify them because we have the same number. So the answer will be CaO. But now, if you want to know the name, like in a formula, it will be calcium. You have to remember that the cation, like the positive ones, are always first, and the negative ones, the anions, are always second. So calcium, and then we have to put 2, because its first ionic charge was 2, here you can see. And then it will be oxide. Remember the IDE. And these are the both answers that you can write. This is the next example, that this is antimony, that it has 51, and this is iron, that it has 26. And then we, as always, we do the electron configuration, and one thing is that you don't need to know the period. That is like extra information, but for finding the ionic charge, we have to know the group, that is the most important thing. And here we have 5A, that it should be Sb minus 3. And then here we have 2A, that it should be Fe plus 2. And then we cross them, and it will be Sb 2 Fe 3. And here we don't simplify them. So the answer will be iron 2 antimonide.